So in this video, we're going to talk about trigonometric ratios or functions, and this is also sometimes referred to as right triangle trigonometry. So right triangle trig. And so basically when you have a triangle, a right angle, we first need to kind of talk a little bit about the triangle. So the side that is opposite of the right angle, that is always called the hypotenuse. And we often abbreviate that as HYP. And then the other sides depend on, you're given some angle. So some angle is identified in the problem. So let's say it's this angle here. And so it's from the perspective of that angle. So the side that is opposite that angle, we call opposite, or OPP, is how I'm going to abbreviate it. And then the side that is next to the angle, that touches part of the angle, right? This side here, that's not the hypotenuse, touches the angle, that's called the adjacent side, or we'll abbreviate that as ADJ. And so there are 6 trig ratios. So 6 trig ratios. And the 6 trig ratios are the sine. So there's 3 main ones. So those are the sine, the cosine, and the tangent. And the sine we abbreviate as SIN, and when we write it in math we say SIN of theta. You have to have an angle here after your sine. So one of the ways to think about it is if that angle wasn't there, right? If that angle was missing here, it's a sin to leave sine by itself. So you need to have something attached. The other reason that you have to have something attached is because, remember, we're going to talk about these opposite, hypotenuse, adjacent, and the opposite and adjacent depend on what angle you're talking about. If I was using the angle up here, then all of a sudden this side is down here is now the opposite, and this side is the adjacent. So it depends on what angle you're talking about, which is why we have to write the angle. So for the sine of theta is equal to the opposite side over the hypotenuse. The cosine, so cos of theta, is equal to the adjacent over the hypotenuse. The tangent, which we abbreviate as tan, so tan of theta, is equal to the opposite over the adjacent. And then there's 3 other ratios, and those 3 other ratios are these 3 ratios flipped over. So to go with the sine is the cosecant, and we abbreviate that CSC theta, and that's hypotenuse over opposite. There is the secant of theta, so secant, and we abbreviate that as SEC theta, and that is the hypotenuse over the adjacent. And then there is the cotangent of theta, so COT theta, and that is the adjacent over the opposite. So if I happen to have a triangle, and let's say my triangle here, let's say here's my angle theta, and this is an 8, this is a 6, and this is a 10, right? So based on this triangle, the sine of theta, so we have to go from the perspective here. So sine is opposite, so opposite that theta, 8 over the hypotenuse 10. So it would be 8 over 10, or we could simplify that to 4/5. The cosine of theta would be 6 over 10. So again, the adjacent over the hypotenuse. So 6 over 10, or 3/5. And the tangent of theta would be the opposite 8 over the adjacent 6. So 8 over 6, or 4/3. And then to get the other ones, we're just going to flip them over. So the cosecant of theta is going to be 5 over 4. The secant of theta is going to be 5 over 3. And the cotangent of theta is going to be 3 over 4. And so one other thing, just again to notice, right, I had to write that theta for each of these. If you write just sine, just cosine, just tangent without an angle here, a theta, an x, whatever it is, that is wrong, and it will get you marked wrong in ALEKS. It will get you marked wrong on a test. So just be aware of that.